Hello, and welcome to our course, Minitab Statistics for Second Language Research. This is Lesson 2. In this lesson, we're going to be talking about measures of dispersion. This lecture is based on Chapter 3 of our textbook, A Guide to Doing Statistics in Second Language Research using SPSS and R. But as you know, we're not using SPSS or R, we are using Minitab. So my job here has been to change all the procedures here so that you can use Minitab. So in our lesson today, we're going to be discussing different issues. First, we're going to be talking about measures of central tendency, the mean and the median, that we already discussed last class. We're going to review quartiles, IQR. We're going to start with new concepts such as range, variance, standard deviation, the normal distribution curve and standard deviations, and then finally we're going to look at implementation in Minitab with all these data that we have for language acquisition. So let's start with measures of central tendency. We already talked about the mean and the median. So remember, we had our fictional hearing data, and we said that the mean is going to be then the average. We take all these values and we divide that by the number of items that we have, and that's how we get the mean. Now this is a measure of central tendency because this is trying to find the mid-value, if you want. Then we also discussed the median, and the median is just the middle of the data. So in this case, we said that the median was 464.5. And if we represent this in a box plot, we said that the box plot represents quartiles, and we have then Q2, second quartile, corresponds to the median. The first quartile corresponds to the first 25%, and then quartile 3 corresponds then to the 75% of the data. Then we defined the IQR, the interquartile range, and we said that this accounts for exactly 50% of the data, the middle of the data. And the way we calculate the IQR is basically we take Q3 and we subtract Q1 from Q3. Now, we're ready then to talk about the range. So here we have our data for the hearing test again. Notice that we said that Q2 is 464, Q1 is 337.8, Q3 is 576.3, and this area that you have here in red, this then represents what we call the interquartile range. Notice the interquartile range covers 50% of the data. So to the left of this we have 25% of the data, and to the right we have another 25% of the data, and that's how we have all the range of the data. Now, with the data here ordered in ascending or descending order, we can have a minimum value, in this case is 268, and we also have a maximum value. This is going to be 739. So the distance that we have from the minimum value to the maximum value, this is what we are going to call the range. And the way then we calculate the range is we take the maximum value and we subtract the minimum value, and in this case is going to be 471. So the range then is going to be the difference between the maximum and the minimum value that we have in our data. The range is the difference between the maximum and the minimal value, in this case 471. We can actually program Minitab, and we will learn how to do this, to calculate the range for the data. So we can do this in Minitab, and we're going to learn to do this. Notice that this is a measure of dispersion. here we're trying to account for how much our data extends. We're trying to see how far the data can go. So this is what we call the range. There's a second concept that we're going to call the variance. Now, remember that we defined the mean in the previous lesson. Now, we can think of a mean in mathematical terms. What is the mean in mathematical terms? Think of the mean as a line. And that line is going to be the line that gives you the minimal distance for all the points in the data that you have. Now, some of those points are going to give you a positive value, like the blue lines that you have there, and some are going to give you a negative value, like the red arrows that you have here in the chart. I don't include them for the little ones because I cannot make the arrows that small. So what we're doing here is we are measuring the distance from the value that we have in our data to the mean. Now, the problem with this, if we add them up, is that the blue ones are going to give us positive values, and then the red ones are going to give us negative values. And we don't want to have a negative variance. So what we do to avoid having a negative variance is we square the values. Okay, so there we have the mean, and we're going to define variance. Now, the way we define variance then, we use the symbol s square, and it's basically the sum, this is the sigma, the Greek sigma letter here, is the sum of all the values that I have minus the mean that I found squared. This is so that I avoid getting a negative number. So I square that, and then I divide that by my number of samples minus 1. This minus 1, think of it like a correction factor. If we're dealing with the total population, then we just divide by n. But when we are dealing with the sample is not the population, then we subtract this 1 as a correction factor. So I repeat then, the variance is going to be what we represent as s squared, is the sum of all the distances from the point of the data to the mean, and then we square that so that we don't get a negative number. That is the variance. Now, once we have the value for the variance, which we have there in that formula, we are ready then to define the standard deviation. What is the standard deviation? Well, the standard deviation is just the square root of that, and we represent the standard deviation with an s. So the variance is going to be the s squared. Now, if we take the square root of that, that is going to give us the standard deviation. So we have two new terms here for measures of dispersion. We have variance and standard variation. Both of these are based on the mean. So this is going to be the distance from each point to the mean. We add all those points, we square them, we divide them by the number of samples minus 1, and then that gives us the variance that we have there. And if we take the square root of all that, that is going to give us the standard variation. This is another measure of dispersion. We can see then how far all these points are from the mean. So this is another measure of dispersion. So coming again back to the data that we had before, notice that in our Minitab we have here the mean and we have the median. These are measures of central tendency. These are measures that kind of explain what's in the middle of all the data. And then we have measures of dispersion. So this is how far the data are going to extend. And then we have the standard deviation and the variance. I have them under one circle here, although they are two different concepts, but they are related. And we also have the range. Okay, so here the values in blue represent measures of central tendency, and the values in red represent measures of dispersion. So our data are going to include then both measures of central tendency and measures of dispersion. Then there's another very important concept that I want to introduce this week, and this is what we call the normal distribution curve. This is going to be central to every discussion that we're going to have in statistics. A normal distribution curve looks like a bell curve, and you're familiar probably with the bell curve. This is a bell curve. It's perfectly symmetrical. So what you have on the left side of the curve is exactly a mirror image of what you have on the right side. And another property is that it never touches zero. Okay, so it goes to infinite, but it never touches zero. And the middle of this curve is going to be the mean. So the mean is going to be right in the middle of this curve. Now, why is this going to be important? Because with this, then we are now also going to include the standard variation. Now, notice that if we count from -1 standard deviation to 1 standard deviation, we will have the area in green, and this area in green corresponds to 68.2 of the data. So 68.2 of the data are going to be between -1 standard deviation and 1 standard deviation. If we look at the data that we have between 2 standard deviations, -2 standard deviations and 2 standard deviations, we will have about 95.4% of the data. And between -3 and 3 standard deviations, we have about 99.7% of the data. You're going to see in lesson 3 how useful this is going to be when we start actually testing further. Let me give you a particular example. So let's imagine here that we have data, and then I have done all my descriptive statistics, and my descriptive statistics has shown that I have a mean of 30 and I have a standard deviation of 5 points. Now, the standard deviation, the mean of 30, this is the line in the middle. So you can see that 30 is right there in the middle. Now, the percentage under the curve that I have between -1 standard deviation and 1 standard deviation, this is going to give me 68.2% of the data. Okay, so all the values that I have under, let's say between 25 and 35, are going to account for 68.2% of the data. The distance between -2 standard deviations and 2 standard deviations, this is going to give me 95.4% of the data. That is to say, considering values between 20 and 40, I'm going to have 95.4% of the data. And if I take 3 standard deviations, -3 standard deviations and then 3 positive standard deviations, this is going to give me 99.7% of the data. Okay, so these concepts are going to be very important when we start doing hypothesis testing in the future lessons. Let's go back then to our original data, and then notice that when we did, for example, the statistics for the hearing test, we got here that the standard deviation was 144.3, and the mean was 467.7. So how do we determine what the value is going to be for 1 standard deviation? So I take the mean and I add 1 standard deviation. So in this case, this is going to give me 467.7 plus 144.3, that gives me 612.0, and then I subtract my standard deviation, and that gives me 323.4. If I do this in a graph, you can see here the graph. I have included all those values, and I have calculated 1 standard deviation, 2 standard deviations, and so on. So notice then that here, between -1 standard deviation and 1 standard deviation, I'm going to have 68.2% of the data. Between 179.1 and 756.3, I'm going to have 95.4% of the data, and between 34.8 and 900.6, I'm going to have pretty much all the data, 99.7% of the data. So this is how we're going to be using the standard deviation. We're going to see how much of the data falls within that domain. Okay, that's it for the theory this week. Now we're ready to go to Minitab. Let's go to Minitab. Okay, so let's open the Kaiser 2000. The Kaiser 2000, and we're going to start with C2, the grammaticality judgment test score for the students over 15. Let's look at the descriptive statistics first. So let's go to basic statistics and display descriptive statistics. So stat, basic statistics, display descriptive statistics, and under variables we're going to enter then the group over 15. Now go to the statistics tab and make sure that you have the mean, the standard deviation, the variance, we know what that is. Take away minimum and maximum, we don't want that. We want the range, we want out the non-missing and the missing ends. Downstairs, take out first quartile, median, third quartile, open the interquartile, and we want the median. So I repeat, upstairs we want the mean, the standard deviation, the variance, and the range. Downstairs we want the median and the interquartile range. Click OK. Click OK. And we got our scores. So we see that the median is 145.14, standard deviation 24.27. We have the variance there, the median, the range, and the IQR. So those are important values that some people do report in their little commentary at the end for the data. Once we have these values, we want to see what is called the histogram. A histogram is a graph. So let's go to the histogram here. So you go graph, histogram, okay, and we're going to click the histogram with a fit, so we can see how the normal curve fares over the data that we have. So click histograms with fit, okay, and here we are trying to do the group over 15, so let's do that over 15 and click OK. We should be getting a graph. Okay, here's the graph that we got. Now, as you can see, this graph and the data that we have here pretty much fit in that curve. Okay, so this seems to be, if it's pretty much under the curve, then we can see that this is normally distributed. And this is going to be what we need to decide before we do any tests, any parametric tests. We need to decide whether the data are, they fit under the curve. In other words, whether the data form a normal distribution. So in this case, it looks like they do. Look at the curve and we can see that most of the data fall actually under the curve, and we can see that the maximum that we have there actually goes pretty much close to the middle of the curve. Okay. However, sometimes it's not going to be very easy to detect whether the data are normally distributed or not. So we're going to apply a different test to see whether our data are normally distributed or not. So how do we do that? So let's put this back. So to see whether the data are normal or not, we go to Stat, Basic Statistics again, Stat, Basic Statistics, and we're going to go down all the way here. There's a tab for Normality Test. So we go Stat, Basic Statistics, and then we go down all the way to Normality Test. Click there. Okay, we are trying to decide whether my group over 15 has a normal distribution. Now, in language acquisition, we typically use the Shapiro-Wilk test. Here it's called Ryan-Joyner. It gives you the same result. Okay, so you click under Ryan-Joyner or Shapiro-Wilk, and that will give you then the results. So there are 3 tests here that you can do to see whether the data that you have are normal. And I repeat, in language acquisition, we typically use the Shapiro-Wilk or the Ryan-Joyner test. Okay, so let's click OK, and let's see what we get. So here we get a graph, and you can see that most of the points are pretty much close to that line that we have there in the middle. Okay, I will not explain the mathematics behind this, but if you can see that the points pretty much stick to the line, they're close to the line, this shows that this is going to have a normal distribution. Now, how can we do this more exactly? So here we have a value, the Rj, this is going to be the Shapiro-Wilk test, and we have a score, but all we need to do is we look at this p-value that you have here. So you look at this p-value. If this p-value is higher than 0.05, higher than 0.05, then we have a normal distribution. So in this case, notice it's 0.1, which is bigger than 0.05, so we do have a normal distribution. Okay, so we can be safe in assuming then that our data are normally distributed. Okay, so all we need to do then is look at this p-value here, and you can look at the drawing. I repeat, look at the drawing. If the points pretty much stick to the curve, like here they do, notice then that we can conclude that this is normally distributed. But if you want a more exact value, then you look at the p-value, and if the p is bigger than 0.05, 0.05, bigger than 0.05, then we have a normally distributed data. All right, so let's click OK, and we are there. All right, so we can conclude then that C2 is actually normally distributed. Okay, let's try the same now for group 1. So for group 1, we're going to go to stats, we're going to calculate the normal statistics. Okay, so under 15. All right, we go to statistics, we make sure that we have the same values. We should, because we're still using the same program. So we want the mean, standard deviation, variance, range, median, and interquartile range. Okay, we get the data, and we can see here that we have the mean, the variance, the median, the range, the IQR, and the standard deviation. Now, we need to determine whether these data are normally distributed or not. How do we do that? Okay, so what we do then is you do here a histogram, okay, with a fit, so we can see whether this is going to fit or not. We go group under 15, click OK, and we're going to get a graph again with a curve. Now here you can see that the data do not seem there are lots of gaps, and we can see that it's not really centered. So here we have suspicions. We may suspect that this is not normally distributed. So what we're going to do then, we're going to do a normality test. Okay, so we close this, and then we're going to go to stat, basic statistics, and then we go all the way down to normality. So basic statistics all the way down to normality. Okay, so here we want the group under 15, and again in language acquisition we typically use the Shapiro-Wilk, so we click under the Ryan-Joyner test for normality, and we click, and we can see then that here, see, the points do not really stick now to the line. They're a little far away from the line. They're very different from what we had before. Compare the probability plot that we got in the other case. In the other case, see, this is what we got first. Okay, so here on the left you have the probability plot for the second group, and here you have the probability plot for this first group. You can see that here they are very close to the line. So here this is a case for normal distribution. Here they're not. And notice that in this case we got a p-value of 0.01. Remember that we need to get higher than 0.05. So if we have something higher than 0.05, then it's normally distributed. So we can conclude then that this group is not normally distributed, but this group is normally distributed. Okay, this will be very important when we do further statistics and hypothesis testing in the future. Okay, so now we want to send all this information to Word so we can write a report. So first we're going to include the data for the two groups. So we're going to do the basic statistics for the two groups. How do we do that? We go to Stat, Basic Statistics, Display Descriptive Statistics, and then here for the variables we're going to include both of them. So under 15, over 15, and then we click OK. And we get the scores for the two groups. We have the means there, the standard deviation, the variance, the median, the range, and the IQR. Let's send this document to Word. Remember that to send it, you click on the chart, and then here you select Send to Word, and this should have sent it to Word. So let's check our Word document. There it is. Okay, so notice that if you click, then this automatically gets sent to your Word document. Okay, then we want to include the histogram for the group over 15. So here we have on the left what we did with the histogram. So you click on that, and then that graph will appear again. And we're going to send this then to Word. So the way to send it to Word, you click on the little arrow here and you send it to Word. Okay, that should send it to Word. It's taken a while. And then we're also going to send the probability plot that we analyzed. So let's click on the probability plot and let's send this to Word. Okay, so we send it to Word. Okay, it's been sent. So let's check our Word document, and sure enough, there is my probability plot for this. Let's make this small so we can fit it on a page. Okay, so let's make it small like that, and there's the other one, the big one, the histogram. So let's click on the histogram and let's make it right here, and you can make it small, and let's see if we can put this chart next to it. So what you do is you click on that, copy, so you do Control C. So you copy that, Control C, and then you move it to this side, so you copy, and then it appears next to it. Okay, so there you have it next to that. If you want to move it, just click on the space. Oh, I went too far. There it is. Okay, and then I can delete this one here. Okay, so there I have my chart then for the group over 15. So we see that the group over 15 seems to be normally distributed, and we can prove that with this chart here, and here we also have the value for the normality test. Okay, let's now transfer the documents that we had for the other group, the group under 15. Okay, so let's go back to Minitab, and we're going to look then at the histogram for the group under 15. Here's the group under 15. Let's send that to Word. Okay, send that to Word. And we're also going to send the probability plot. So click on the probability plot. Okay, and we're going to send that to Word as well. Alright. So now we have the second group there. Alright, it should be in Word, so let's go to our Word document. Okay, so here is the probability plot for the group under 15. Let's make it small, so we can fit it on one page. And let's take the other one. Here's the histogram. Now we can see that most of the data points are not inside the curve, and the curve has lots of gaps inside. So let's try to make this as close as we can to the next one, to the previous one. So we have that there. We might want to make this a little bit smaller too. There we go. And remember, copy, and then click on here on the side, and then click. We have it there. If you want to move, just click on that and then move it with the double space bar, and we delete this one here. And there on this page then we have our report. So we have the basic statistics, okay, with here we have with the different measures of dispersion and central tendency. So we have the mean and the median, those are central tendency, and we have the dispersion measures, the standard deviation, the variance, and the IQR. Okay, and then we have the charts. So the charts basically show that in this case we do have a normal distribution, and in the second case we do not have a normal distribution. Okay, so this is the way then that you would transfer your graphs and your data to a Word document. You will need to do this for the projects for this week. Okay, time has come to summarize what we have learned today. If you remember, in lesson 1 we read a report about an experiment, and it said an independent samples t-test was conducted with a group of older participants who took the L2 phoneme discrimination task M467.7, S144.3, N equal 10, and young participants in the 30s M709.6, S106.8, N equal 10, blah blah blah. Now, these first two lessons have been dedicated to understanding that first part of this report. In other words, understanding what M, the mean, means, S, the standard deviation, means, and N, the number of samples. So now you know how to read that this particular experiment. Then the group, older group, had a mean of 467.7 with a standard deviation of 144.3, and the young participants, they had a mean of 709.6 and a standard deviation of 106.8. Now you understand what that means. Today we discussed measures of dispersion, and we were talking about two kinds of measure of dispersion. So first we talked about the range, and we said that the range then was the distance, if you want, from the minimum to the maximum value. And the way we calculate that is we take the maximum value, we deduct the minimum value, and that's how we get the value for the range. Then we took the second measure of dispersion, and this was the variance, and the variance is connected to the mean. So what we do in the variance is basically we add up all the distances between the value and the mean, and then we square them so that we don't get a negative number, and that is the variance. Now, once we understand the variance, we were able to define the standard deviation. The variance is S squared, the standard deviation is just S. So S is just the square root of the variance that we discussed before. Then we saw how we could get these values programming Minitab, and we saw then that the values in blue, those are values of measures of central tendency, and the values in red, those are measures of dispersion, which was the main topic for the lecture today. Then we talked about the normal distribution curve, and we saw then that the distance between minus 1 standard deviation to plus 1 standard deviation covers about 68.2% of the data. The distance between minus 2 standard deviations to 2 standard deviations covers 95.4% of the data. And we finally saw that the distance between minus 3 standard deviations to 3 standard deviations covers 99.7% of the data. This will be very important because, for example, imagine you're trying to replicate an experiment, and you say that you're 95% sure that the results will be within a particular range. Then notice that if you are within, let's say, 2 standard deviations, then you will make the correct prediction. We will see more of this later. Then we saw the importance of testing for normality. So whenever you start a parametric test or any kind of testing, you need to see whether your data are normally distributed. And the way to do that then is with the aid of a histogram. And then we learn how to do a histogram and then impose the normal curve on top of that. And then also we learn how to do what we call a probability plot, and we learn how to read a probability plot. The probability plot basically tells us whether the data are normally distributed or not. Sometimes we can tell simply by looking at the histogram on the left. Like in this example, you can see that most of the data are pretty much following the shape and also are in the range of the normal distribution curve. However, looking at the probability plot, we can see this a little bit more exactly. The more that the different points there are closer to that line in the middle, the more that the data that we have are going to be normally distributed. However, the real measure for this is going to be the Wilkins-Shapiro test, and this is what the RJ here stands for. And all you need to do is read that p-value. If the p-value is higher than 0.05, I repeat, 0.05, higher than 0.05, then your data are normally distributed. Then we saw an example that would not be normally distributed, and here we have the other example. So you can see here that the data has gaps, and a lot of the data falls outside the normal distribution. When we do the probability plot for these data, we see that the points are far away from the line in the middle, and in fact when we check the Shapiro-Wilkins test, notice that we get a value of less than 0.01. Now 0.01 is less than 0.05. Remember, we need to get more than 0.05 to decide or to prove that the data are normally distributed. So in this case, here we have data that are not normally distributed. Okay, time has come for us to discuss our projects for next week. The first project is going to be from Larson, Hall and Connell, 2005. You have already worked with these data. The paper is called Evidence from a Critical Period, Remnants from Forgotten Languages. This is a paper they presented at a conference and it's not published. Here they are going to give a reading, writing, listening test, and they had three groups. One group that had never been in the US, another group that had been in the US when they were kids, so this is the early group, and one group that were there when they were adults, so this is the late group. So your mission consists of 5 different tasks. The first one is to make a synoptic descriptive statistics chart that is going to include the mean, the median, the IQR, the range, the variance, the standard deviation, and the skewness for all 3 groups. Then you're going to show a box plot for the 3 groups, and you're briefly going to discuss what the box plots show. Then you're going to show a histogram with the normal distribution curve on top for each group. Then you're going to run a Shapiro-Wilkins test, and you're going to show the corresponding probability plot. Then you're going to discuss whether the data for each group are normally distributed or not, and you're going to discuss the values for the Shapiro-Wilkins test as well as the value that you get for skewness. The second project is from Lister, 2004. This appeared in an article called Differential Effects of Prompts and Recasts in Form-Focus Instruction. This appeared in Studies in Second Language Acquisition number 26. Here she had 4 groups, and group 1 was the form-focus instructed group with prompts. The second one was the form-focus instruction group with recasts. The third one was only with the form-focus instruction, and number 4 contains a comparison. Now here we will be concentrating only on groups 1 and 2. A prompt will be when a student makes a mistake, you correct the mistake and you make the student realize the mistake. A recast is when you repeat what the student said and then basically the student has to figure out what was wrong. And they were trying to see if this actually made a difference. So your mission is pretty much the same as what you had for project 2A. You're going to make a synoptic descriptive statistics chart, including the mean, the median, IQR, range, variance, standard deviation, and skewness for all three groups. Then you're going to show a box plot for all three groups, and you're going to briefly discuss what the box plots show. You're going to show a histogram with a normal distribution curve for each group. You're going to run the Shapiro-Wilk test for each group, and you're going to show the corresponding probability plots. Then you're going to discuss whether the data for each group are normally distributed or not. You're going to discuss the values for the Shapiro-Wilk test, as well as the values that you get for the skewness. So this brings us then to the end of lesson 2. I hope you learned something new. I hope you can apply this to your research, have fun doing the projects, and I will see you then next week. Bye bye for now.